Hello everyone and welcome to Time to Fly Drone and AI Tutorials. In this video I'll be starting a new series, Explained, where I'll go over technical concepts related to drones and AI. For this video I'm going to give an overview of the very first clustering algorithm I learned, KMeans. In part 1 I'll show you how to use KMeans with the Scikit-Learn library, and in part 2 I'll show you how to implement our very own KMeans algorithm. Now let's get started with KMeans Explained. Before diving into the code, I'm going to give a quick overview of how the algorithm works, some applications, as well as pros and cons. K-means is an unsupervised clustering algorithm that tries to group data points based on how similar they are. In order to determine whether features of samples are similar, we can use several similarity functions. A popular one is simply Euclidean distance. Our goal is to assign each data point to one of K groups such that all of the groups have similar valued features. The better we assign these groups, the lower our loss, and the better job we have done at clustering our samples. Now I'll walk through an example to visualize these steps. Let's say we're given an example dataset of the location of homes, and our features are latitude and longitude. And now let's say our assignment is that we want to group these homes based on their physical locations, meaning that we want to find the neighborhoods of these homes. Well, K-means is a perfect algorithm for this because it's a clustering algorithm, and that's exactly what we're trying to do. Looking at this dataset, we can already see that some groups seem to be formed. There's just one in the bottom left, one in the middle, and one in the bottom right. The first initialization step of K-means is to assign a K value, or we assign the number of clusters or groups that we want as a result. For simplicity, we're going to use K equal to 3. The next initialization step is initializing random cluster centers. We can look at this as an initial estimate of where the centers of our groups are going to be. Because we have K equal to 3, we have 3 groups. We have the red group, the blue group, and the green group. The first actual step in K-means is now cluster assignment. This is where we look at each data point individually and determine which cluster center it is closest to. And this is how we actually create our groups. So looking at these 3 red data points, we can tell that they're actually closer to the red X than they are to the blue X or the green X. This is why they're assigned this red color. The same can be said for the blue data points and these green data points. After we've essentially created our groups, we've assigned our clusters, we now update the cluster centers. And we do this by taking the average of the features of each group. So looking again at the red data points, we have these 3 red data points belonging to the red group. In order to update the center of this group, we take the average of the latitude values and the average of the longitude values. And this position is where the center of the group should be. Once again, we do the same for the blue group and the green group. Now we can see that we're kind of at a state similar to the initial problem, that we have 3 centers and we have all these data points. This is because K-means is an iterative algorithm, meaning that it's going to perform the same steps until it reaches a final state. And this final state is determined when the 3 cluster centers don't move a whole lot. So this basically means we've found the centers of our clusters and now we can stop. So continuing the iterative process, we're back at cluster assignment. We can see that a little bit has changed. However, the red group is still the same. The blue data points now have increased to 4, and the green data points have been reduced to 5. Updating our cluster centers, we can see the blue and the green groups move slightly, while the red one remains roughly the same. So this algorithm may need a few more steps to finalize the exact position of these centroids, but once it's complete, we've reached the final state or the final values of our centroids. So the result of this algorithm is the position of the 3 centroids, or the values of these centroids. So for this red X, it'll have a latitude value and a longitude value, which represents the center of the red group. And the same can be said for the blue group and the blue X, and the green group and the green X. Now let's look into some of the applications, pros, and cons of K-means. Let's say you're a market researcher for your company, and you're trying to learn more about your customers. You can use K-means to group customers based on their interests, preferences, maybe some products they bought before, or maybe future products. Doing this, you can try to target ads or products to these specific customer groups. You can also use K-means to segment images based on pixel values. And let's say you have a really large and complex data set. You could potentially use K-means to create subgroups in this data set and do different predictions on these subgroups to try and minimize the complexity of your data set. One of the things I really like about K-means is that it's a pretty simple algorithm. When we look into the code, you'll notice that there are only a few steps and they all seem to make sense. However, there are some problems with K-means in that it does not have a global solution. Basically, what this means is that every time you run the algorithm, you may get a different result, meaning that the values of your centroids or your cluster centers may differ a little bit. Also, K-means works best for kind of circular and uniform data. It doesn't work well for funky shapes, and we'll see an example of that. So I'm running this video with this Jupyter notebook, and if you want to follow along, I added a GitHub link in the description, so you can also download the notebook and check it out as you watch this video. So now let's get started with some Scikit-Learn examples. First, what I'm going to do is load some imports that are useful, and in this cell we can load the K-means module. I'll come back to this elbow method a little bit later once some things have been clarified. So for this first example, I'm using this make blobs just to make a random data set. It's got 100 samples and 2 features. And here we've got the data set. We can see that some groups have been formed. Maybe they're 4 groups, 5 groups, kind of depends on what you're feeling. So in this cell here, this is where we actually can run K-means using Scikit-Learn. The only real parameter you need to worry about is the number of clusters. This is our K value. So let's just select K equal to 4 initially. So we run it with K-means with num clusters equal to 4. We then fit our data set with X, which was created using make blobs. And then we predict. What this predict is doing is determining which cluster each of these data points belong to. So this is the cluster assignment and update centers steps from the animation. And here we have our cluster centers. These are simply the feature 1 and feature 2 values of each of the centers of our groups. So we can run this. See, that's very quick. And now let's plot our results. We can see that we have the 4 groups as we specified. We have the blue group, green group, red group, and orange group. And these black stars indicate the centers of our groups. So we can see that K-means it did a pretty good job. This is clearly one group, this is clearly a group, clearly another group. But this orange group, you see, it might be able to split in 2. So instead of K equals 4, let's try with K equal to 5. So running K equal to 5, rerunning K-means, and replotting it, we can see, yeah, this makes sense. It's a pretty fair assessment. These could be split into 2 groups. Now you may be wondering, well, if we need to select K, how do we know which K is the best? Well, that's the problem with K-means, is that there's no closed form solution, meaning we can't know the value of K beforehand. It's purely kind of experimental. And this is where a neat little method comes into play, which is called the elbow method. So what the elbow method does is it just runs K-means for a bunch of values of K. It fits our data set and it records the loss and then just plots the loss. Using this, we can analyze the plot and determine which K value is the best for the data set. So for this make blobs data set, if we run the elbow method with K equal to 1 to K equal to 10, we get this neat little plot. So we've got the value of K on the bottom, so the number of groups we assigned, and the loss on the vertical axis. So in determining the correct value of k, or the best value of k, there are several conditions we need to look at. If we're looking at these low values of k, these low conditions, well, they've got a very high loss, meaning that the centers of our groups don't really characterize or describe the data set very well. So we want to avoid those values. So we want to avoid 1 and 2. Now when we're in this horizontal region, it seems like we're in this kind of asymptotic region where the loss stays roughly the same as our k value increases. Well, we also want to avoid this region because even though the loss seems to be getting slightly smaller, by increasing the k, we're simply just increasing the complexity of our model, and we always want to keep things simple. So that leaves us with this middle region, this pocket, or the middle of our elbow, with k values of 3, 4, and maybe 5. Well, we can see from our data sets that a k value of 4 and 5 did a pretty good job of clustering our data into respectable groups. So this elbow method just kind of verifies that a value of k of 4 and 5 does a pretty good job. So this data set had nice values. They were all kind of these circular data points or circular groups, and we could easily cluster them. So KMeans did a great job. However, let's look at an example where this might not be the case. So in example 2, I'm using the makeMoons function to create these kind of two hemisphere moon-like shapes. So one thing to keep in mind is don't confuse the blue and these orange colors for the actual labels of the data. They simply represent that these are supposed to be two distinct features, or two distinct groups, a blue group and then this bottom orange group. So because we have these two shapes, we logically should think, well, we have two groups, so let's use a k value of 2. So we'll run KMeans with 2 clusters. We have the same fit function, same predict, same cluster centers. Let's run this and let's plot our results. And well, that's not what we expected. That's completely different from our results up here. And this highlights one of the biggest problems with KMeans, is that it can't capture this complex data set or the structure of the data. These arcing shapes just don't fit well with KMeans because KMeans is trying to grab data points that are all a similar distance away from a center. And a shape that best resembles that is a circle or a sphere or some hyperplane that represents a sphere. And these two data sets, or these two structures, clearly don't represent a circle. And that's why KMeans does struggle a bit. So plotting the elbow method, we can see that an optimal value of k in this case is 2, 3, maybe even 4, but clearly that's kind of invalid for this data set because KMeans will never really be able to capture this data set well. That wraps up my KMeans Explained tutorial. Hopefully you got a good feel of how KMeans works and how to use it with Scikit-Learn. In part 2 of this little series, I'm going to go over the inner workings of KMeans. So how KMeans actually implements cluster assignment, how it actually updates the centers, and how you can actually predict using it. So stay tuned for part 2 of this video. Also, if you use this notebook and found it helpful, definitely star my Time to Fly Drone and AI tutorials repository so that you stay up to date with more code examples for this video and for other videos. Also, subscribe to my YouTube channel so that you get notified when part 2 of this video comes out. Once again, if you have any questions or suggestions for this video or about KMeans itself, just drop them in the comments below. Thanks for watching and stay tuned for part 2.